So you've got a PySpark interview coming up, maybe even breathing down your neck. Hey, don't panic. Think of this as your ultimate last-minute playbook. We're going to sharpen your answers and build that confidence so you can walk in and absolutely ace it. Okay, so here's our game plan for today. We're going to start with that quick 30-second pitch, then we'll dive right inside the Spark engine. After that, we'll hit the core architectural questions, tackle some senior-level scenarios, and then wrap up with those tricky performance and debugging traps. Let's do this. All right, first things first, we have got to nail the fundamentals. You know that first question is coming. So, can you tell me what PySpark is? We want a sharp, confident answer right out of the gate. And there it is. This is your perfect elevator pitch. You see, it's not just a dry definition. It shows you get the whole point. It's about combining Python's simplicity with the raw distributed power of Spark. I'd commit this one to memory. Now, when you talk about features, the key is to highlight the data frames API. Your interviewer wants to know that you understand why it's the recommended way to go. So you should mention that data frames let Spark's Catalyst optimizer work its magic, automatically figuring out the best way to run your query. That's a huge advantage over the old school RDDs, and it'll make you sound like you know what you're talking about. Okay, let's pop the hood and go a little deeper now, into the engine room. Honestly, understanding these internal mechanics is what really separates a good candidate from a great one. Get ready for this one because it's an absolute classic. They're not just looking for a definition here. They're testing if you can actually visualize the entire journey, from the moment you write your code to when you get a result. And this slide, it lays out that journey perfectly. But don't just read the steps back to them. You've got to explain it. Make sure you put a little extra emphasis on step 2, the Catalyst optimizer. That's the brain of the operation. It's the part that intelligently rewrites your code to make it run way faster. Mentioning it by name shows you know exactly where Spark's secret sauce is. Now, this is a really crucial point. Execution memory always wins. It has priority. So if a big shuffle or join needs more room, Spark will literally kick cached data out of storage memory to make space. Understanding this is key to debugging performance problems because it explains why a job might suddenly hit a wall when a big memory-hungry operation kicks in. All right, time to shift gears into those core architectural questions. Look, you are almost guaranteed to get asked about these, so let's make sure your answers are absolutely rock solid. This one is huge. The whole design of Spark is literally built around this idea. So a shaky answer here is a major red flag. Let's break down exactly what a perfect response sounds like. The magic word you have to use is lineage. Explain it like this. Spark doesn't waste time and space copying data all over the cluster just in case something fails. Instead, it keeps a recipe, and that recipe is the lineage. It's the exact set of instructions for how to create every piece of data. So if an executor dies and its data vanishes, no big deal. Spark just pulls out the recipe and recomputes the missing piece from scratch. It's so efficient and honestly pretty brilliant. Okay, picture this. The interviewer leans in and asks, what's the very first thing you check when a Spark job is running slow? Your answer should be instant. Without a moment's hesitation, the shuffle. It is without a doubt the most expensive operation in the entire Spark universe. Now, knowing what causes a shuffle, like a group by key or a join, that's good. But explaining why it's so bad? That's great. You have to mention that a shuffle involves writing a ton of data to disk on one set of machines and then slinging all of that data across the network to another set of machines. It's that brutal 1-2 punch of disk I/O and network I/O that just kills performance. Okay, let's level up. Anyone can answer a what question, but a senior engineer, they answer the why, and more importantly, the when. This next part is all about thinking like an architect. I love this question. It's a fantastic test of your practical wisdom. It shows you're not just a fan of a tool, but that you understand its limits. You know when to use it and when to leave it on the shelf. Answering like this shows real maturity. You're not just a Spark expert, you're a problem solver. You get that Spark is built for batch and micro-batch processing. It's not a database for super fast lookups, and it's not a true real-time streaming engine. Knowing how to pick the right tool for the job, well, that's the mark of a true senior-level pro. Now, if the conversation shifts to system design and they ask you to sketch out a data pipeline, this is the pattern you want to have ready to go. It's a huge standard in the industry, especially in the Databricks world, and it proves you know how to build modern, reliable data platforms.
Being able to confidently walk someone through this on a whiteboard is a huge, huge win. You explain how data flows from its raw, messy state in the bronze layer to getting cleaned up and structured in silver, and finally aggregated into business-ready insights in the gold layer. It shows you're thinking about data quality, governance, and the end user. And finally, let's talk about what to do when things go sideways. Because let's be real, in distributed systems, they always do. Knowing how to debug and steer clear of these common traps is absolutely critical.
Ooh, this is a great follow-up. Everyone knows that caching can help, but a senior engineer knows when it can actually make things worse. This question is a test of your real-world, hands-on experience.
And here's the kicker. Caching is not a free lunch. It eats up that valuable storage memory we talked about earlier. If you try to cache something that's just too big, you'll start spilling to disk. And what's even worse is that you can put a ton of pressure on the JVM's garbage collector, which can literally pause your entire application to clean up memory. Caching is always a trade-off, not some magic button.
Broadcast joins are usually your best friend for joining a big table with a small one, but they have a pretty spectacular way of failing that you absolutely need to know about. The most important detail to mention here is the driver's memory. See, a broadcast join works by sucking the entire small table into the driver node's memory first, before it shifts it out to all the worker nodes. So if that small table is actually much bigger than you think, or just bigger than the driver's available RAM, the driver will crash and your entire job fails. It's a critical bottleneck to understand. So as you walk into that interview, just keep this one thought in mind. It's not about listing features, it's about explaining the trade-offs. Why you'd pick one strategy over another, when caching makes sense and when it's a terrible idea, and when you should step back and say, you know what, Spark isn't even the right tool for this. That is what's really going to impress them. Now go get them. Good luck.